Hello and welcome to this new tutorial, and in this tutorial we are going to see how we can do text line segmentation from images using Emgu CV. In case if our text is not horizontal, then we will apply some skew correction techniques first to make it horizontal, and then we will perform line segmentation. And for line segmentation, we will be using some techniques like contours, binarization, and other morphological processing so that we will have the final output just like as shown here. So let us get started. I will continue with my project which I have started from my previous videos. This one uses Emgu CV 4.5.1. So the first thing that I'm going to do is to add a menu item. So in the menu strip, I'm going to the collection, and under this process, I'm going to the further collection, and I'm going to add a new menu item, and we can call it text line segmentation. And I'm just going to copy this and also write here without spaces. Okay, click on OK and click OK. So I'm going to the events, and from the events I can select the menu item that I just created, text line segmentation, and I will create an event for this click. So I'm going to double click on this event. So whenever the user will click, it will come to this event. So the first thing I will do is to write a try catch block so that if I have any errors in my code, it should throw an exception. I assume that the user has read some image to display in the picture box, and I'm going to use an if condition to make sure that the user has opened a file, and we put this one in a dictionary imgdict, and I can check it by writing this contains key, and for the input I use this key input. And if the image is present, or if it is not present, I should say, not img.dict contains input, then we can throw an exception, throw a new exception object, and we can pass an optional message, please read an image. So the first thing that I will perform is the skew correction. Let me create a method for skew correction. If there is any skew, then we will diskew it. So I'm going to create a new method, and this one will basically return another image. There should be a bgr, and depth will be in bytes, so we can call it this skew image, and we will pass in an image itself. So we are considering a color image, so bgr and byte will be its depth, and let me call it img. So what we will do here is to apply the deskewing and return the image after skew correction. And to make sure there is no error, I'm going to create a try catch block here. Let me call this an exception ex, and then we can return a new exception object with this message that has been passed in by the compiler. And here what I need is I need to convert this actually into a binary. This is a BGR image, so we need a grayscale image to process it. So what I will do here, we can convert it into a binary image. We call it variable binary. So img.convert, and let us convert it into a grayscale image. So gray, and its depth is in bytes. And to make sure that the things are okay, maybe we can reduce the noise by applying a Gaussian smooth Gaussian. and I'm just using a small kernel of 3, which means that only 3 by 3 neighborhoods are considered. The next thing I can do is, this is the image that I want to process. So the background is white while the text is in black. But I want my text to be in white color and a background in black. So I need to apply a thresholding. And in fact, I'm going to use an inverse thresholding when my background is white. So we can use any threshold if this value is less than 400 and 240, then replace it with 255. Remember that this is what the inverses do. And one more thing that I want to do is to, if there are some disconnections within the characters, I want to apply a morphological processing to combine them together. So one more thing that I want to do is a morphological dilation, and I want one bounding box, and using that bounding box I want to discrete this one. So what I will do is I want to apply a morphological, this is extensions, and there are many operations that what we want to perform is just the dilation, so that I want to combine all of them together into one component. And next is the kernel. So I need to create a kernel. So here I'm going to create a kernel. We may call it kernel or structuring element. So I can use a mate dot ones, and I'm going to select a bigger structuring element, let's say 15 by 15, so that all the text I want to combine them together. So def type, it will be just unsigned 8, and I have only one channel. And this structuring element will be used to apply this morphological processing. The anchor point that it considers is -1, which means that we are going to use the central pixel to apply this processing. The number of iterations I want is 1, and border type, just I want to, let's say, default, whatever they are going to use. And in case if we have some problem at the borders, what we will do, I say, okay, set its value to be 0. It's not a big problem for us. And since the dilation will make the things a little bit bigger, and to make sure I erode one time to bring it back into its original size at least. So I'm trying to do that. So after this, what we will get, let's return it and see the results so far, what it did actually. So I'm going to return this binary, but it will think that this binary is okay. I'm going to return null, and we can show, just for the sake of showing it, image is equal to binary dot 2-bit main. Okay, let me run this and see if there is something happening or not. Output is equal to, we can call this method, and we can read the image. Variable mg is equal to imdict, and this is the image, input.clone. I'm just going to make a complete copy of it, and we can pass this image there. So let's see what it has to show for us. Okay, and then we apply the text line. So this is what exactly I wanted. So we have only one connected component, and now I need to find out its bounding a rectangle and then the angle that I need to rotate it to correct its skewness. So that is important. So find the bounding box of that white object. So let me call them points is equal to new vector of points. We need those boundaries as vector of points. And we can apply this CV invoke dot find non-zeros. So this will return them from this binary image and put those in this points. Okay, that is awesome. So all the points will be copied here. And then I can find the bounding box by calling it, let's say, min area rectangle. We can use CV invoke dot min area rectangle. So this min area rectangle will return us the angle also, the center of this object, and also the bounding rectangle from these points. So this is what exactly they are giving us. The most important point is the angle here. So we will be using that angle to rotate it. And to perform a rotation, I just need to create some variables. So call it rotation matrix. I need a rotation matrix so that I can perform the warp affine. So new mate, and this one will be a 2 by 3 matrix, and its depth will be just, remember that it should be 32 float, and the channel is just 1. And let me create another variable for just to copy this, what we call it, rotated image, and this will be the same as the input image. So I just going to create a blank which will be the same size, but it will be blank. So I use this copy blank method. Now let us display the bounding rectangle also, and to find the corners of that bounding rectangle we can use what we call it box points. So let me find the corners of our min area rectangle. So I will be using CV invoke dot box points. So this one, when we pass this min area rect, it will give us those points, the four corner points. And this one is basically returning the point in float. So to display them, we actually need an integer. So I need to convert it into what we call it, the integer. So what I'm going to use is the link query. So x is the input. In fact, I can create a new point. So new point, and this one will be basically x dot x comma x dot y. And again, we can convert them into, actually, I need to convert, this was the image, I need to convert them into integers. So I'm just going to convert them into integer, and then we can convert back into the array. So now we have a point array of integers. Okay, now I want to draw those four corners to see what things are going to happen. So integer I is equal to 0, and we have corners dot length. So how many corners do we have? CV invoke and dot, we can draw a line between two corresponding points. So we want to draw this on our image, and point 1 will be the corners of I to the next point in the corners. So we are selecting corners of I plus 1. So okay, I plus 1, and another parameter is what should be the color. So we are going to give a color. For example, I want to make it BGR. It means it will be in gray color, and the thickness you can select any. For example, I want to select the thickness too. But remember here that I'm drawing the points between I and I plus 1. And remember that I also want to draw a line between the third point, sorry, from fourth point to the first point also. So what I will do is, in fact, I plus 1 percentage 4. So this one, when we go to the fifth, so between 4 and a fifth, actually we don't have fifth, but when we do this percentage 4, it will 0. So it will draw between a fourth and the first point. So this one will draw the points and we are already showing it. Let's see if we can draw them. Okay, text line segmentation. And now you can see this is what exactly I wanted to draw. And also we can number them, like which is the first point, first, second, third, fourth point, and also we can show them. So what we can do here is I just want to put a text here. So we can write CV invoke dot put text on this image, and we can I.toString. I want to show I.toString. This is the text that I want to show on these corners. Let's say corners of I. And the font face that we can use is the simplex or whichever that you want. And scaling is just like this. I want to keep it, and the color that I want to select is a red color, so BG, and red is 255, and thickness I want a little bit bigger than. And also if you want, we can draw a circle on that point. CV invoke a circle, for example, IMG, and the center will be on this corner, so corner of I, and the radius, let's say we can select a small radius circle, let's say 3, or if you want in a new color, and I want to select, let's say it blue one, 25500, and the thickness, if you want, let's say 5 to fill it. Let me do it like 1.0. So let us run it. Process and text line, so that is perfect. So this is the 0, 1, 2, and 3. Now we really need to understand that the angle that we receive from the minimum area rectangle is always between the first point and the last point along the x-axis. So when we have the x-axis, and then you can see this will be the angle. Actually, we know this angle. And to discrete it, I need to rotate it a little bit in clockwise direction. So the angle will be just this, my whatever the angle I have here, 90 minus this angle. And to do it in the clockwise direction, we will provide a sign of minus. So this is really important. And so for this scenario, we will have to rotate it by this angle, this much angle. So let's see how we can do that. Actually the documentation that is written, the angle will be always between minus 90 and 0. But for this case, when I tested and I verified that the angle, it is not giving any negative angle, irrespective of whatever I am doing it. Even I calculated myself. Somehow, to deal with that issue, what we really need to do is to find the actual angle to rotate it, to discrete the image. So what we will do is angle. We have the angle provided by this mean area rectangle, and I want to provide a condition. If this is less than 45 degrees, then we don't need to do anything. We will use this rectangle dot angle as it is. Okay, but if this angle is greater than 45, so the scenario which I shown before, I just want it to be rotated in the clockwise direction. For anti-clockwise, I don't need to provide a sign. So what I will do, minimum area rect dot angle minus 90. So this much I want to rotate in this direction. So this angle, once I calculate it correctly, what I will do is we can calculate the rotation matrix to rotate all those pixels according to that one. So CV invoke dot get rotation matrix, 2 dimension. Okay, and this one is requiring the center using which we want to do the rotation. Okay, this is the center of rotation of the source image, the angle that we just calculated, we want to make a rotation using this one. The scaling, we are not going to do any scaling, so I just keep it as it is. And this one is the destination or the output matrix, so which I already created and called it the rotation matrix. And now using that rotation matrix, we will rotate our image. So I'm going to use the cv invoke dot warp affine, and this one is asking for which image you want to perform is the image, and the result that we want to store is the rotated image, and this one the results will be transformed according to the rotation matrix into this one. And the matrix that we need to provide is the matrix rotation matrix. What should be the size of the destination? It should be the same as we have the source image. That's why I provide img size. Interpolation, this one is doing linear interpolation, which is a little faster. It's just, let's keep it as it is. And the border is constant. Let me keep it as it is and then see what happens. And we hope that this one will perform the rotation, and by the way we can display this rotated image, and let's see the results. That's text line segmentation. So now you can see that the rotation has been performed using the correct angle, but I don't want this background. So instead of the constant, I can do a replication of the border, so that will help us to imitate the exactly the same background. So here I'm going to provide this border mode will be border mode dot replicate. So let's do text line segmentation, and now you can see that the rotation has been performed. And in fact now we don't need to show these things after the transformation is being done, and it looks okay. So instead of showing it here, now I will return my rotated image. So this one method will disgive my image, and what we can do here, we may call it rotated image, for example, and here we can display the rotated image as well as the original image, both of them together. And let me say output is equal to, in my previous videos did I create any of these methods? I don't remember. CV invoke dot horizontal concatenation. So we have this method. Let me try to concatenate these two images, img and the rotated image, together. Okay, so once we do the skewness correction, the next thing that we will do is to segment the text line. So let me go and create another method, and let's call it private. And we can do two things here. We can return the image, the output image, as well as we can return the bounding boxes. So this one will return a tuple, so image, the image on which we are going to draw those bounding boxes, and it will be of type byte, as well as a list of rectangles. These are the bounding boxes around each line. And let's name this method as detect text segments. So this one will take the image as input. So image bgr byte. Let me call it image. And for the dilation which we will perform, let's say we can take a kernel. By default we are going to set it to null, and if we want to draw them or not, so let's just keep them as two parameters. So we are taking two things, the kernel for performing the dilation and this image. And let me write a try catch to make sure that we don't have any problem. So new exception ex.message. So it will throw this message if there is any error. And once we have done it, the first thing I will check if my kernel is equals null, then we must create our own kernel. So let me say the kernel is equal to mate.once. And remember that I want to combine these horizontal texts together. So the dilation operator must be smaller in height and a longer in width, in its width. So I'm just selecting a 3 by 9 kernel columns, and the depth type that we want to select should be an unsigned integer and just one channel. Okay, so if user doesn't provide, we will do our own. And the next thing that we will do is once we have the image, we need to binarize it and convert this background into black and the text into white. So we can call it binary is equal to img.convert. We do not need any color information, so I'm going to convert it into a grayscale image first. Followed by, we can simply do a not operation, which means that the white pixels will be black, black pixels will be white. And if there are some noise, to make sure that I want to now apply a threshold binary because I already performed a not operation. Or if you don't want, we can also do something like this. We can directly do the inverse and binarization, and we can pass it like 240. If it is greater than 240, remove that pixel, and if it is less than this one, convert it into this color. Okay, and then I want to apply this morphological processing, and the morphological dot dilation that I just want to perform. And the kernel that we want to use is the size that we have defined earlier. And the central point we want to perform according to this center point. So we provide -1, -1. If you want to select any other pixel, then you need to provide its value. And the number of iterations is just one. And sorry, this border type dot let's say we select a default. We are not actually using this. And the scalar, I just want to set it. Maybe the background is white, so I did it 255. And that's it. So we did the binarization and followed by morphological processing to combine the text in one horizontal line into one connected component. I need some variables. Let me call it temp is equal to img.clone. I might need it. I'm just making a clone or a copy of my original image. And now I need to find out the contours. So variable contours, I'm creating a new variable of vector of points. So this one will store the contours. We need another made object. We can create it to store the hierarchy, although I'm not using it, but since the method needs it, it is mandatory, so I need to create this object. cv invoke dot find contours. This is the most popular method I'm mostly using. So we are using this binary image as input, and we want to store the contours in contours variable hierarchy in h. And the retrieval type, I am only interested in the external boundaries. So I selected this external. And the chain approximation method will be the simple. So when we do it simple, it means that for a rectangle, for example, it will not give us all the points in the border. So only the 4 corner points are enough to construct that one. So chain approximation simple will do the simplification. Now I need to return the list of rectangles, that is the bounding boxes for each contour, and also if you want we can draw it then. So I have to loop through the contours. So before looping I need to create a variable, call it bboxes, bounding boxes, new, it will be a list of rectangles actually. Bounding boxes is nothing, just a list of rectangles. And then we can loop through all our contours. So contours dot size. So now I want to find out their bounding boxes for each contour. So bounding box is equal to, we can use this method, cv dot bounding rectangle, and this one is expecting a contour. So I'm going to pass each contour one by one. So we generated or created the bounding box, and we can add that bounding box into our list of bounding boxes. So bboxes dot add, I'm going to add this bbox, okay, because I'm going to return the list. And if we want, we can draw the rectangle also here. So cv invoke dot rectangle, what was that, rectangle, we are going to draw this rectangle. And on which image are we going to draw it? That's why I created this temp. So I call it temp, and the B box is the what I want to draw the rectangle, and we need to provide a color for it. So I'm going to provide a red color, blue, green are 0, and the red is 255. And the thickness, I'm going to make it a little bit thicker, so I set it to 2. So this one will draw the contours. And I think everything is ready and we can return them. So what I will do is return. Remember that I need to return a tuple, and this one is expecting a BGR image, which is our temp, on which I have drawn my contour, and also the list of rectangles, which is B boxes. I'm going to return them. By the way, the contours inside this B box may not be sorted uh, according to our lines. For example, maybe it will not give the first contour, 0 will not be representing line 1, line 2, line 3, line 4. But if you want to sort them, it is also possible. So here you can see that the y-axis is basically according to y-axis, I can sort them out. So before returning them, what we can do is bboxes is equal to bboxes dot order by, and it will be in ascending order. So let me write a lambda expression dot according to y. So I'm going to sort them by y and then again convert them back into a list. So this one will sort them by list according to their y coordinate, and then we are returning them. Now we can use this method to receive those here. So as a tuple, so we can create, let me call it Emgu. So this one is going to receive the image, and then B boxes, this is going to receive the bounding boxes. So let me call it detect text segments. And this one basically expecting an image. So we are going to pass the rotated image because we already rotated it. And by default, I want to use the kernel as I defined below. And if it doesn't give me good results, then I can provide my own kernel. So just I provide this because that is an optional argument. And then we can test it by showing this image, picture box one dot image, and let us see what it gives us. Image 2 dot 2-bit mail. Let us run it. So this is the original image, and when I click on text line segment, as you can see that it has perfectly segmented the text into different lines, and it has drawn the bounding boxes around them. And that's it. Hope to see you in next video.